like to present my talk. It is called Theoretical Approach for Low Energy Nuclear Reaction using the BSM-SG atomic model. What's this atomic model? In fact, it is my theory that I developed 15 years ago. I had many conference presentations. Here I show the main book, the basic structure of matter superconduction in time theory, and another book, Structural Physics of Nuclear Fusion. So what is the point? In 1929, when Einstein developed his theory of general relativity, he had a difficulty for explanation of the space curvature. So in his book, Sidelight of Relativity, he clearly speaks about the existence of ether. And he says that without existence of ether, quantum mechanical properties could not be explained. You could find this book, it is digitized. So I investigated hundreds of articles about the experiments to arrive to the idea, what is the problem? What is this ether that is ignored from the modern physics? And I arrived to the idea that in fact this ether, the space we live is not pure empty like Einstein considered. It contains some kind of structure that I call the cosmic lattice. It is not a chaotic structure, it is organized structure. And the building blocks of this structure are so tiny, they are much beyond any observational levels. I estimated they are 10 powers of minus 20 of the meter. But analyzing the experiments from different fields of physics, I logically arrived to the detailed physical model of this structure. And not only this, I arrived to the models of the elementary particles and atomic nuclei. And it appears that the building blocks of this cosmic lattice, that is so essential, built also the elementary particles. And, these building blocks in elementary particles, they are more complex. They are like a helical structure. They are more, and these building blocks are super dense matter. And then I arrived to the conclusion that around the atomic nuclei exists space curvature, like around the big objects. But this curvature is even much stronger because the matter is super dense. And this makes a problem of correct estimation of the scattering experiment. And because this also makes a problem, the quantum mechanics to give the real physical dimensions. Because quantum mechanics works only on energy levels. But the real physical dimension is so important in nanotechnology, important in the new search for the new safer energy, atomic energy, but safer. And then I focused, so after deriving this structure of the elementary particle atomic nuclei, I focused on the low energy nuclear reaction, so-called cold fusion. Because in the latest year there was a big breakthrough in this field. And the power that before, after about 25 years from the Fletcher and Bones experiment was investigated, suddenly was raised from watts to kilowatts. So here I give a brief summary of the recent results of this low energy nuclear reaction or cold fusion. And even there is now ongoing project called Micro-Information Memorial Project, that is open project, and scientists from all over the world participate, and they get very interesting results. They really get that energy. What they interesting that they get is also X-ray radiation in a lower level, and this is not so. Even this speaks that it is not a chemical reaction; it's a nuclear reaction. So not only this, but the results investigated from different places, and they found that changing of the elements appears. So this is just a brief summary of this experiment. And this is the detected X-rays. They detected in a number of places. So why the quantum mechanics I consider is not a real physical model. The first one is that I mentioned it doesn't take into account the field curvature around the atomic nuclei. That is pretty strong. And the secondly, it has only angular resolution, but not transversal resolution. And because it was adopted from the time of Rutherford, he made scattering experiments with energy to 25 mega electron volts. And he extrapolated further, so the nucleus was estimated in the size of 1 femtometer. But later, in 1961, they found a sharp deviation. Not only this, but the recent modern experiments, they have much complex signature of atomic nuclei. But because they use the same assumption that all particles and atomic nucleus are spherical, of course they arrive to, and also don't take into account the space curvature, they arrive to the same results. So it appears that now the new energy that is much safer,
fusion,
is not supported from mainstream because it is not explainable. Because from the point of view of the quantum mechanical models, when the nucleus is 1 femtometer, the Coulomb field is so strong that we need a million degrees. But it appears that it becomes degrees of 300 to 1,000 when experiment. So, what's the atomic model that I derived from elementary particles? The proton is shown here. It is like figure 8. In fact, and the neutron is below, is double the laser. This one. Oh, yeah. So this is the proton, and this is the neutron. In fact, it is one and the same structure of a torus, that it is folded like number 8, and this is double folded. But here, so in fact, the electrical field is distributed around this structure, and it is much larger. You see 167 angstrom. But in the neutron, the electrical field disappears in the far field because the supergravitational force just locked in the closer place. But when the neutron is moving, it exhibits magnetic moment. So, using this structure, I start to build the atomic nuclei and to see how it matches to the periodic table. So this is proton, this is neutron, hydrogen with different. The electronic orbit here appears well-defined shape because they are guided by the electrical field of the proton. And here deuterium, lithium, helium-3, helium-4. And further, going to the periodic table, perfect match to the shape of the periodic table. And also, why I say supergravitational law? Because I can consider in the pure empty space between the knots of the cosmic lattice, it is this similar to the Newton's law, but inverse proportional to the cube of distance. It appears just the nuclear forces in very close distances. In the far distances, they become they become so small that neglected. So for example, here is the example of two-row periodic table from lithium to neon. And here, using pure logical thinking, you could see how adding one and more protons go to the periodic tables and how valences are changing until it becomes a novel gas. It's another row. And also, going through all the periodic tables, we'll see why the actinides and lanthanides to go outside of the table, then return again. It is pure 3D space considerations. Also, you see how the electronic orbits, for example, this is helium, interact between them and get a magnetic field. You could build molecules, for example. This is the ozone molecule. Having this structure is very easy to show why some molecules are straight and other are bent. And this is extremely important for the structural physics, not only structural physics, but for the this is extremely important for biomolecules, where the shape, different shape of this, in fact, is controlled. Because it appears here that the valences, they have some limited directions, like hardware restrictions. Here, example of argon mock-up. Argon mock-up. Here I show the Coulomb field around the proton, around the neutron. When the neutron is over the proton, it becomes deuteron, but it is in the middle, and because they interact, the neutron will rotate. It's very interesting. When neutron is rotating, it creates magnetic field. And this is very important further for explanation of the nuclear magnetic spin. Here I give example of some arrangement in the heavier nuclei, and here I show some examples of nuclei, some elements. I think this, having in mind this structure, it is very suitable to make modeling in nanotechnology. Here I show a simple example, for example, of analysis of single sheet of graphene, carbon sheet here. This is the transmission electron microscope. And here I just make adjustment of this picture. You see every second atom is dimmed. And why is this? Because this is the carbon atom. And this is the true proton that make two valences. It is another two, but they are in the perpendicular direction. So when you make this image, you will receive this. This and many other things, in fact, match the model that I suggested. Here is the illustration of the Coulomb barrier in hydrogen, deuterium, lithium, helium. Here, for example, for silver. And this, in fact, gives an easy explanation of nuclear magnetic moment. Because the magnetic moment of the rotating neutrons, this, I show it again like this, over the protons create a magnetic field. And this field interacts with the magnetic fields of the electronic orbits from the lower shell. But these lower shell orbits are fixed. So, in fact, they match with the magnetic field of the neutron, and then the nucleus possesses a few stable magnetic spin states. And this experimentally observed feature provides a base for the field of quantum computing. Here is another consideration, for example, for the Rydberg state of the atom. It is very easy to explain this state of the atom, for example, for the hydrogen. Here is the hydrogen proton, here is the electronic orbit, here is the deuterium. When the electronic orbit is in this way, there is not electromagnetic radiation, only optical. But if it is excited and the electron goes outside, it is still attracted by the electrical field of the proton. But in this case, his magnetic moment, that is 630 times greater than the proton, appears apparent and detectable. And not appear when many such rubber atoms, they align in the cluster because interaction of the magnetic field. And this feature called Rydberg matter plays very important role now investigated in the cold fusion reactions. Here, let's see which elements, for example, are suitable for cold fusion energy. This is the element from here, from number 6 to here. They are transmetallic elements. To make a low energy nuclear reaction, we have to take one heavier atom and one very light, for example, hydrogen. Because in this case you change the binding energy with a small amount. Constantly we have to apply a lower initial energy. And also to make a minimum nuclear refurbishment in the fusion process. Why is this? Because if you make this, you get a minimum or almost lack of radioactive waste. And now the nuclear energy makes so much radioactive waste that it is the biggest contamination that the human society has. It is estimated that accumulation of 25,000 metric tons nuclear waste is accumulated so far. Every year increase it with 12,000. And there is not recycling can cure this. Only the time that is measurable with millions or maybe billions of years. And by going to new energy of cold fusion, in fact, you could eliminate any waste because it is possible to predict what kind of reactions will not give such. Here is just an example of nuclear fusion. When nickel and hydrogen gives copper. So in fact, this is the nucleus of nickel, look is the hydrogen. The hydrogen in the Rydberg matter, they interact positively with the proper nuclear spin, it becomes a fusion. So in this case, you get the nuclear energy, cold. In my theory, I estimated one important factor of the supergravitational law, this factor. And I estimated it by investigating the hydrogen and deuterium molecules, where the atoms are very close. I received this value, and then using this value, I theoretically estimated the binding energy of the deuterium, and I obtained a very close value to experimentally apply. So there is a number of considerations that comes from here that are very useful, not only for cold fusion, but for the nanotechnology, for the chemistry, or the investigation of biomolecules, nanomaterial property. So this is one book that I, especially for structural physics of nuclear fusion, that I explained this. Here is the calculation of the potential reactions, some of them. This is another examples using these models. They're very convenient for computer modeling. This is another options of nuclear reaction that in fact is practically achieved. This is also explanation how this reaction appears, how the Coulomb field is disturbed by approaching. This Coulomb field, this lithium is disturbed by the approaching of the Rydberg hydrogen. Result, one slow neutron is separated and it makes another reaction. So This is example of some practical results explained by these models. And these are the conclusions for practical considerations for safe and nuclear energy. And this is, in fact, the periodic table of the element from hydrogen to 103. This nuclei. And potential application of these models. They are very easy for, very suitable for computer modeling. So, one of many BSM models producing the chemistry, nanotechnology, low energy nuclear reaction as a 3D graphical modeling with a sub-angstrom resolution. A number of articles are pointed here online. Also, my books are for sale by Amazon.com. Thank you.
One short question. Okay, please.